Hello everyone, my name is Sandeep Webb and today we are going to solve one problem of Leetcode and that problem is backtracking string compare. Okay, so we try to understand this problem with a flow, and the flow is first we try to understand the problem, what is the problem statement. The next is we understand the approach to solve this. The next, I want to give you a tip in order to solve DSA problems, and there is a second approach that we are going to use. Okay, so let's come to the first thing, which is understanding the problem statement. So what is the problem statement? We have given two strings, okay, S, and the another string is T. Okay, if we have to return true if they are equal when both are typed into a text editor. Hash means a backspace character. Note that after backspacing an empty text, the text will continue empty. Okay, so let's understand this problem. So problem states that we have a given string. So let's suppose we have a string like a b hash c. What it means, it says that here we have basically in this problem we have two strings, and this string contains two things. One is lowercase English letter, and the another thing is hash, which is a special character here. And this hash is basically represents to backspace. Okay, now problem said, let's suppose this is the string, we have to iterate this string, and wherever we are getting this hash, which is a backspace, at that position we don't have to consider its previous character. Okay, let's go through this string and try to understand it. So let's suppose this is A, then we write B, but at this position we are getting hash, and hash means backspace, it means we have to delete this p. Now we are getting c, so we can join this. Now after iterating this string, we are getting a new string which is ac. Similarly, there is another string we have which is t, so this string is a, d, hash and c, right? So let's go and iterate it. First is a, then we have b, then we have hash, which means backspace, so we don't have to consider it, and then we have c, and in that case we get a new string after iteration which is ac. And now you can see this t string and this s string both are same, that's why we have to return true. Similarly for that case, let's take one more test case in order to understand this problem more clearly. So we have a string which is a hash c. Let's iterate this. First we have a string which is a, right? Now this is a. Now in the second position we are getting hash. What it means? It means a backspace. It means we don't have to consider it. Next we are getting c. So here we are getting c. Now let's take the next string which is t, and here we have only b. Let's iterate it. Here we have b, so we have b as an output, and when we go next, this pointer is out of bound and this is b. Now you can see c is not equal to b. In that case we have to return false. Now the first thing, which is understanding the problem, is fine. You are able to understand the problem, I hope. Now let's go to the first approach, how we are going to solve this. See, whenever we are going to when we are trying to solve some problem in DSA, it is not about how we are solve it, okay? It is about, okay, when we solve it, what things we consider and what things we are not consider. Okay, What it means, let's understand it. So we are given two strings, right? S and another string is T. Let's suppose A, B hash C and A, D hash C. What is the first approach which comes to your mind? I hope everyone thinks in that way. What we do, we are taking some stack or taking some another data structure and going through this full and going through this string, right? And we will create a new string. How? We simply get A, so we push A, then we get B, then we push B. At any point when we get hash, we simply pop it. When we get C, we simply add C. This is the stack 1, right? Similarly, we can take stack 2. This is A, we can push A. This is D, we can push D. This is hash, we can pop it out. This is C, we can add it. And here we are getting C. And here we are getting AC. Now we will compare these and we can return true or false according to the character present in this stack. This is a very basic approach. Anyone can do this. But now, to be a good programmer or to be a good problem solver, we have to think, can we optimize it or not? Okay. So let's talk about the time complexity here. So basically you are taking two stacks. Let's suppose its size is n and its size is m. So you are basically whatever the maximum of these two, you are basically using big O of n time complexity, and if we talk about this space complexity, it is also big O of n. Now the next question we have to ask, okay, so this is basically the first approach we cover. Now let's talk about the tip. So see, tip, whenever you are trying to solve some problem in Leetcode, right? Okay, and you solved it very easily. After that, let's think, okay, if we are using some stacks or if we are using this data structure to solve that problem, can we use another data structure to solve this problem or not? If you can think and you can code it in another way, that's a very good point. And if not, you can go check out other people's solutions and understand from there. That is one of the best thing in order to learn data structures and algorithms. Okay, so let's go to the second approach now and understand it. Okay, so this is the second approach. Okay, now we know very well what is happening, like we have given a string, right? A, B hash C hash D. Here we can see we only have two things. What are those two things? We have some characters and we have a special character which is hash here. And this hash basically tells it is a backspace, right? And we only want those character which is valid. Valid means which is required in order to make comparisons. It means, let's suppose if there is a hash, it means simple that this C is of no use for us, right? Similarly, if there is a hash, it means there is no use of B for us. So whatever the remaining characters we have, that is the only thing we need to compare, right? So we look. So this is the basic intuition in order to solve this problem without using any extra space. Okay. So let's take the example and understand it. S and then there is a T. Two strings are there. Simple example, A, B hash C and then A, D hash C. Great. Great. So what we are going to do, we simply traverse from the last. Why? Because let's suppose if we are at this position and if the character is not hash, then we can simply take it and compare it. We don't have to think that if there is a hash we have to consider it or not, right? But when we start traversing from the last, whatever the things we have, we can simply validate it. Great. So the approach is, let me give the indexing. Okay, initially I have I which is at position 3, I have j which is at the position 3. All right, now let's do this. So for I, right, for I will check whether it is a safe position for me. Yes, it is a safe position, right? In that case my I is equals to the 3. Let's check j is the safe position. Yes, it is a safe position, it means it is j. Now we can compare. So there we have c and there we have c, it means both these characters are equal, right? Right. Now let's decrement this by 1, now it becomes 2. Now let's decrement this by 1, it becomes 2. Now we are at this position. Now we will check if it is a safe position. No, why? Because it is a hash, it means we are not going to consider it. So what we do for that, we basically create a counter which is initially 0, right? And whenever we are getting some hash, we will increment it by 1. Okay, and then decrement this index to this. Now we will check this counter. If it is greater than equal to 1, then we will decrement it again. What this counter signifies? This counter tells that there is one hash which tells not to consider that index. Okay, so now it is 1, so we will not consider it and make it 0 again. And now we will reach here. Now this is a non-hash character, it means we can consider it. So the considering point is 0. Now for the j we are at the 2th position, it is a hash, and when it is hash we will increment the counter. Now we reach here and we check the count is greater than equal to 1, it means we have some hash in counter. Then we will not consider this, we will go there and we also decrement the counter by 0. Now we reach at 0. Similarly j is 0, right? Now in that case you can see we have same characters. Okay, now let's move there and let's move there. At the end we will check the index I which is -1, j which is -1, and both these index are equal. And that's how we check if these two index are equal, it means we traverse both these strings, then we have to return true, right? Otherwise we have to return false. Here the time complexity is big O of n, but we are not using any extra space, that's why its space complexity is big O of 1. Now for more understanding, let's see the code. From there we can understand more. Okay, so in starting we are traversing from last, and this is one function which is safe index. What this function do, it basically gives us index which is required to compare. Okay, so what we do, as I discussed, we simply have a counter, and if the character is a hash we will increment the counter. If it is not hash, we will check. If our counter value is greater than equal to 1, it means we don't have to consider that index and decrement our counter. Otherwise, we have to break it and we have to return that index. This is a safe index. Okay, this is a safe index. Now, after getting these two safe index, we will check the boundary case. Okay, if it is out of boundary, we have to break it. Otherwise, if the characters values are not equal, we have to return false and decrement it. And in that position, we have safe index. It means we are checking at the last that both these strings traversed completely, and if these index values are same, then we have to return true, otherwise we have to return false. Okay, I hope you like this video and please subscribe. Every day I will try to create videos for you, and please comment out so that I can improve the video also. Thank you.